So the title is Subtraction with complement. Okay. So here the idea is this. We want to actually make one hardware, which we call that the adder. For example, you have some hardware which you label that adder. We will design that in the lab, and in the lab you will design an adder. So what adder means? So suppose adder, you have 2-bit adder, which is able to add two numbers which they have 2 bits and give the results on the other side of your circuit. Okay, so whenever you add two numbers, suppose this is number A, this is number B, each of them has a 2 bits. Whenever you add, we will talk about that, but definitely you will get 3 bits, because it is possible you add two numbers with 2 bits and the result will be the 3 bits. So that's the reason you have actually 3 output. Okay, so you design this, then you want to actually make some changes on these adder. So here what you have as output is A plus B. Okay, you want to actually change on these hardware, and you actually make one subtractor. What is the subtractor? So if this is subtractor, 2-bit subtractor, definitely should be same, right? You actually get A and you give the B, the output should be actually again 2 bits, because whenever you subtract two numbers, somehow it is impossible it's make a carry, right? You subtract 2 bits with 2 bits, definitely the result will be 2 bits. That's what I just showed 2 bits here as output. So it gives you actually the A minus B. Okay, so we call this adder, which is clear from name. Add two numbers, give the result. This is subtractor, subtract actually two numbers, give the subtraction. So definitely you have 4-bit adder, 5-bit adder, 2-bit adder, which is means each of these A and B could be has any number of the bits, right? So this just 2-bit adder. So what we want to actually explain here, which is the title is Subtraction with Component, you design the hardware to add two numbers, right? Then you don't want to actually design another hardware to actually make a subtractor. You want to somehow use the subtraction with complement, which is just again you calculate the subtraction by adding that number with actually its r's complement or it's actually r minus 1 complement, and use these two and able to get the a minus b. Okay, so that's what we say subtraction with complement. Somehow you want to use the complement and just you want to use adder to make a subtractor. Okay, so this is what we want to do. Okay, so that means you don't want to design have everything again for the subtractor. You just want to have these adder as a hardware. So then actually use the subtraction with complement concept and use the adder and able to subtract the numbers. Okay, you will see this later, but for now I just want to give you an idea of what we have the subtraction with complement, which is the idea is just use the adder to calculate the subtraction. This is what we want to do. So let I get rid of these short introduction that I had here and see how we could do that, how we could get the subtraction with just using the addition. Okay, so okay, let I actually add one more line here, which is good to have on your note. So we say the subtraction of of two n digits unsigned numbers. You actually label one of them as a m, the next one actually cap n. I mean m minus n in base r, which is we suppose in the general case we are in base r, can be done as follows. So can be done as follows. So which is one of them use the r complement, and in the second method we use actually the r minus 1 complement. So let's see how we could do that. Let's start first with the r's complement. So I actually put number 1 is just use r's complement. So let's see how we could actually calculate the subtraction with using just the addition, right? So you just need to follow these steps, okay? I summarized the steps. That's on the book. I summarized that here. So you want to do m minus n, which is, you already know the m and n is the two number in base r. Here I mentioned to them, okay? You want to calculate the subtraction, but you don't have any hardware to do the subtraction. The only thing you have is the adder. You could add the numbers. So for doing that, you say, okay, I could do this. I could just add the m with the n prime, which is n prime is the r complement of the n. So here I actually write some comment. The n prime is the r's complement of n. Okay. So you want to do m minus n, so you do first m plus the r's complement of that. So let's see what else we need to do. Forget this subtraction. So the next is, so see, I'm summarize that. So if actually sum, which is this sum that I mentioned here, if sum actually produce carry. So what it means, it's produce carry. So see, you actually add these two numbers. So if the first number has, for example, 5-bit and the next one has 5-bit, if you add these two numbers and the result is 6-bit, you actually say we have a carry. Carry is 1, okay? If this is 5-bit, this is 5-bit, you add two 5-bit numbers and got the 5 bits, again, you say carry is 0, okay? So in more general case, I could say whenever I add one number with n digits with another number which has n digits and the result is n digits, so the carry is 0. If the result is n plus 1 digits, the carry is 1, okay? So that's the meaning of this carry. So if the sum produce carry, it can be discarded, okay? It can be discarded. So you just ignore that, okay? So we will have some example. You will see how you could do each of these steps, okay? So this is actually step 2, and the last step is if sum does not produce carry. So that means you add two numbers with 5 digits, the result is 5 digits. So that means there is no carry. So carry, what you need to do, you need to take the r's complement, of the sum and place a negative sign in front. And place negative sign. So write the next here in front. We will have an example for all of the cases, okay? For now, so you want to calculate this subtraction with using just addition. You say, okay, I add second one, takes our complement of that. So this addition has two possibilities, make a carry or not carry. If that's make a carry, is this step, okay? If produce carry, it can be discard. That means ignore the carry. Whatever you got is the m minus n, okay? So if you actually doesn't have the carry, so that means carry is 0, you just again take the r's complement of the sum. So that means whatever you got as an m plus n prime, again you take the r's complement of that and also add one negative in front of that number. That should be the result for m minus n. So I'm writing the same thing for the using the r minus 1 complement, then have example for each of them, okay? So this is how you use the r's complement. You could actually have the same things for use the r minus 1 complement. So let's see how you could use that. Use r minus 1 complement. So let's use the same color here. So again, the same story, right? You want to do this. You want to subtract two numbers, but you don't have any hardware to make a subtraction. You just have the adder. You could just use the addition. So for doing that, you need to say, okay, m plus n double prime. So which means the r minus 1 complement of the second number, okay? So let I just add this. So what I put here as a double prime, the n double prime is the r minus 1's complement of n. Okay, so you just add with the r minus 1 complement of the second number. So let's see what should be the different scenario that could be happen. Definitely, these will be two scenario that you have. You have a carry or you don't have carry, right? So I'm writing here the same thing. So the first scenario is if some produce carry. Produce carry means carry equal 1, okay? So then this is if this is a case, you need to do this, removing the carry. And add 1 to the sum. Add 1 to sum. So what it means, whatever you got, you just add that with the 1, okay? So that will be the m minus 1, give you what is the m minus 1. So again, we will have a couple of examples for them. For now, let's just finish this. So the second case is if we actually add with the r minus 1 complement and the sum, if sum does not doesn't produce carry. So that means carry is 0. So if this is a case, this is what you need to do. Take the r minus 1's complement. Take r minus 1 complement of the sum. And place a negative sign. And place negative sign in front. Okay, so I just review all of them. So you want to do this subtraction, which is m minus n. M and n is two numbers in base r. So you want to get the subtraction with just using the addition, right? You want to just use the addition. You don't have any hardware to do subtract. You just want to, the only thing that you have, you could just add the numbers, okay? But you want to use that addition hardware to able to get this result of the subtraction. So there is two methods for that. First, use the r's complement. The second one is r minus 1. Actually, if you want to use the r's complement, you need to follow these three steps. If you use r minus 1, use these three steps. So the first, if you use the r's complement, you want to have m minus n, you need to calculate m plus n prime, which is the n prime is the r complement of the n. So then you have two cases. Case number one, carry. Again, if you add two numbers, both has an n digit, the result has n digits, the carry is 0. If result has n plus 1 digits, the carry is 1. So you have two cases. Carry is 0, carry is 1. If carry is 1, which is say here, if sum produce carry, means carry is 1, it can be discarded. Just ignore that carry. Whatever you got as a result of this sum, it actually is m minus n. We will do that. You will see it works. So if the sum does not produce carry, so that means if carry is 0, whatever you get the result as a m plus n prime, you need to take the r complement of that and put the negative sign in front, okay? So this is for r's r using the r's complement. So if you use r minus 1 complement, you want to do m minus n, do m plus n double prime, which is n double prime is r minus 1 complement of n. Again, you have two cases. Case number one, carry is 0. If some, sorry, the case number one is carry is 1. If some produce carry, means carry is 1. Remove the carry and add the 1 to sum. Okay, if you compare these two cases, the difference whenever you use r and r minus 1, in the r, whenever carry is 1, you just ignore that. But for the whenever you use r minus 1 complement, you ignore that, but you add 1 to the result. Okay, so this is the difference between these two. So case number 2, if actually carry is 0, again similar with the previous one, take r minus 1 complement of the sum and place the negative in front. So these are, the second case is almost same for both of them, but here you take the r's complement because you use the r complement. Here you actually take r minus 1 complement. Okay, so I think we talk enough. So let's have one example for that. Okay, so in the example we exactly follow the same thing that you see here. Okay, so let's actually start with base, probably the base 10, which is more makes sense for you. So I have one example and see how interesting is this. So see example here. You want to do this. You want to do 16 minus 15. Okay, so definitely you know what's the result, but here we want to follow with this whatever we learn, which is following the r's using r and r minus 1 complement. Okay, I want to subtract 16 minus 15, but I don't have any hardware that able to do the subtraction. Okay, I just could add two numbers. Okay, so I say, okay, let you use the r's complement. First, I use the r's complement. I'm in base 10, so use r's complement means use the 10's complement. I say, okay, based on what you learn, so we are actually here, right? So I want to calculate m minus n. Here m is 16, n is 15. I'm in base r. I'm in base 10, which is r should be 10. So for doing that, you just calculate m plus n prime. What is the n prime? Is the r's complement of n. So that means first I need to calculate this 16 plus the 10's complement of 15. You tell me what is the 10's complement of 15. That's for how I get the 10's complement. First non-zero, subtract from r, which is 10. So that means it should be 5 and all other digits from 9. So should be actually 85, right? So 85 is, yeah, 23rd is the right one. So whatever you have here, the 85, so that should be in actually prime, okay, based on what you have here on the node, okay? That's, I just take the 10 complement of that. So then what you need to do, you need to add these two numbers. So it is maybe more nicer to do this. So say, okay, 16 plus, I write in this way, that able to easily add that two numbers. So should be 85, okay? So you actually have 6 plus 5 is 11. You have one here, one here. So you are on base 10. That should be easy to add these numbers, right? So 8 plus 1 plus 1 is 10. You have 0 here. You have 1 carry, which is comes to here, okay? So what we did, we are actually in these steps. See, we are here. So you tell me which of these two cases happen. So the sum produce carry, or the sum actually doesn't produce carry. This is which of these two cases. So you are here, right? You add, so that's actually carry. Yeah, the carry is 0 or 1, so that means we produce carry or not. So definitely, as mentioned, you add these. The first number has a 2-digit. The second number has a 2-digit. You add two numbers with 2 digits. What you get is 3 digits. So that means you have the carry, and carry is 1. So see, this is this case. So you say if sum produce carry, so that means this is this case, not this one, okay? So second one does not carry. So here you have carry because this is 2-bit, this is 2-bit. What you got is 3-bit, okay? So that means you have the carry, okay? If sum produce carry, what I need to do, it can be discarded, okay? So that means you just ignore this. Whatever you have, the rest should be the 16 minus 15, which is 0, 1. So 16 minus 15 is 1. Yes, that's 1. So that's right. So see, it works. So these two is works, right? So which is interesting. So that means what's really they use from this concept, they say, okay, I design the adder, the hardware for adding the numbers. I don't need to design a subtraction, a hardware to subtract numbers. I could use these two concepts and use the adder to actually make a subtraction. So you will do exactly this in the lab. So that means first in the lab, you make one adder, which is able to add 4 bits number. Then you make actually the small change on that, and you change that to the subtractor, okay? So let's have another example, which is 90 minus 11. So you want to calculate the subtraction. You are on base 10, and you want to use the same, actually, the concept that I explained, okay? So let's actually do this with using the R complement. So that means tens complement, okay? So based on what we learn, so we say, okay, if you want to subtract 90 minus 11 and you don't have the hardware to do that, you're just able to add two numbers. We say, okay, I'm adding the 90 plus the R complement of the 11. You are in base 10, R complement is actually 10 complement. So question is, what is the tens complement of the 11? Tell me, what is the tens complement of 11? Tens complement of 11? You could actually type on that box. 89, that's right. So you subtract first one from the R, which is 10, so, and the rest from the 9. So that means it is 89. So let I write here 89. So then erase this back here. So you actually add these two numbers together, and then you just add. So you say, okay, 0 plus 9 is 9. So 9 plus actually 8 is 17. You couldn't have 17. You write 7 here, then 1 as a carry, and you have these numbers, okay? So what I did, I just add with the R's complement, which is 10 complement of this. Then We actually back here with what we learned in our last class. I'm using the R's complement that you see. So if some produce carry, which is for our case, actually it's produce carry, right? So you just need to discard the carry. So in other words, you just need to ignore that, okay? So that means I just need to ignore this. Whatever you have here should be 90 minus 11, right? So see, 90 minus 11 is 79. So see, it's actually works in base 10. This is another example. So you have two numbers. The first one is x. So x is 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0. Okay. And the second number is, you label that y equal to 1, you have 4, 0, 1, 2, 3, 4, and you have 2, 1. Okay. So the question is, use actually do this, calculate x minus y by using the 2 complement. So x minus 1 is a question, and we just want to use 2 complements to get that 2 complement. Okay, so we exactly know, you just need to follow what we learned in our last class. You say, okay, you keep the actually x, you need to actually add, so that I first write the x, which is 1, 1, 0, 1, 2, 0. We actually add this with actually the 2 complement of these y. So that means 2 complement of these numbers, okay? So you tell me, what is the 2 complement of the y? This is your y. You need to take the 2 complement of that. So what I'm doing here, I'm actually doing x plus. Yeah, I need a second. Okay, I give you a few minutes. Just 1 minute is enough. 21. So you just tell me what is the 2 complement of these y that you see. So technically what I'm doing here, I want to follow what I learned in our last class. I want to do x minus y. So first I need to calculate x plus y prime, which is the 2 complement of this number. So remember, 2 complement of the number, you say the first non-zero from the right. Yeah, you keep it. So I keep the first one here, which is no change for this first one, okay? So then rest 0, 1, 1, 0, okay? Or you could say the first non-zero subtract from 2, which is 2 minus 1 is 1. The other subtract from r minus 1, which is 1, right? So that means all change 1 to 0 and 0 to 1. So that means here should be have 0. So then you have here 4, 0, which is changed to 1, 2, 3, 4, 1. And the last one should be 0, okay? You add with 0, 4, 1, 0, 1, okay? Exactly follow what we have on our notes, okay? So then you need to add these two numbers. We talk how you could add two numbers in the binary, right? So you say 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 1 is 2. Subtract from 2 is 0, and you got the carry. Again, 1 plus 0 plus 1 is 2, 2 minus 2 is 0. You got 1 carry here, 1 plus 1 is 3, 3 minus 2 is 1. You got the carry, and again, you say 1 plus 0 plus 1 is 2, 2 minus 2 is 0. You got the carry here, and again, you have 1 plus 1 is 2. You couldn't write 2 here, you need to subtract from 2. Again, you got the 0, you got another carry here. If you consider 0 here, you got actually 1. So that means what you got as a sum is 1, 0, 0, 1, 3, 0, 1. So you tell me, this is which of these two cases? This carry is equal to 1 or carry is 0 here in this addition that we did? What is the carry here? 0 or 1 for this addition? 1, right? Why? You actually back here. You say, okay, how many x has how many digits? 1, 2, 3, 4, 5, 6, 7. So this has 1, 2, 3, 4, 5, 6, 7. You add two numbers with 7 bits. What did you get? 1, 2, 3, 4, 5, 6, 7, 8, right? You add two numbers with 7 bits, so it's actually made one numbers with 8 bits. So that means the carry is 1, okay? So I just ignore the carry, which is whatever you have here. So if you ignore that, so you could say x minus y equal to 0, 0, 1, 0, 0, 0, 1, okay? So that's actually what you get based off these, actually the concept that we learned in our last class. This is important because I mentioned in our last class. So we design a hardware for the adding two number. So we call that 4-bit adder. It's able to add one 4-bit number, which is A, another 4-bit number is B, right? So whatever you got as a result in this hardware is A plus B. So then you are not going to design another hardware to subtract to these two numbers. You just make a small change and use the same concept and able to actually subtract that two numbers. How? You keep these A and you add, again, this is an adder, but this time you actually put not B here. You add that with B prime and check the carry, and based off the carry you make a decision what should be the output. In other words, you use the same concept, same hardware that you have here, and you are able to make the subtraction. You will do that in the lab, okay? So we will actually design exactly these two, the adder and subtractor in lab, but we need to know about this concept because you use that in actually in lab. So the second section, let's do this. Use the same concept. We did x minus y. So let's do y minus x and calculate this. Okay. So you know x, you know y. This time you actually want to do 1 minus x. Okay. So right now we want to do y minus x, right? So just be careful. You already did x minus y, so it is this. If you say 1 minus x, this should be the same number, should be just negative, right? So if you did the right thing. So if I say 5 minus 2, the answer is 3. If you say 2 minus 5, the answer is negative 3, right? So somehow you could check your answer is right or wrong, okay? So let's do that and see what we will get. So first, we just follow what we learned. So you want to do 1 y minus x. So as usual, we say, okay, keep the y. So I'm doing this, y plus the r complement or 2 complement of the x, which is the x prime. So let's calculate this first. So what is the y? Y is 1, 1, 2, 3, 4, 2, 1, right? So plus the question is, what is the 2 complement of the x? So I rewrite the x here, which you have the x is 1, 0, 1, 0, 1, 3, 1, 2, 0, okay, 10, 10, 100. So what is the 2 complement of this, which is the x prime? What is the 2 complement of x? This is a good practice for how you could get the 2 complement of the number. Just type in the chat box, what is the, yeah, so see, you say this, just be careful. Whatever you have, the zeros on the right side, there is no change. You have 2 of them, right? And the first non-zero from the right side, there is no change. So that means so far you have here. Or we say you keep the zeros that you have on the right, and first non-zero from the right, subtract from the r, which is 2. You subtract this, which is the first non-zero from the right, from the 2, 2 minus 1 is 1, or no change, right? So it is all others from r minus 1, which is 1. If you subtract these numbers from 1, 0 change to the 1, and 1 change to the 0. So that means you will have a 1, 0, 1, 0. Okay, so it should be this number. Okay, so you need to add the y, which is 14011, with this number, which is the x prime, which is 0102100. Yeah, that's right. So that's actually simple addition in the base 2. So I'm doing that 0 plus 1, 0 plus 1, 0 plus 1 is 1. Here is straightforward 0. This is actually 1. This is 1. Okay. So now tell me, the carry is a 0 for these actually addition or 1? The carry is 0 or 1? Carry is 0 or 1? Is 0. Why? You add again two number with the 7 bits, you got actually the 7 bits as a result. So carry is 0. So carry is 0. Back to our notes. Okay. So if there is carry is 0, you use these R complement. This is right now, it is the second one. Okay. So then it says if sum doesn't produce carry, which is this is a case this time, take the R complement of the sum and place the negative number in front of that. Okay, I need to take another 2 complement of the result. So I need to take a 2 complement of whatever we got. So now tell me, what is the 2 complement of these result, these number that you see? What is its 2 complement? Type on the chat box. What is the 2 complement of 1101111? So let's see. So see, again, there is no non-zero on the right side. The first non-zero from right, subtract from 2. So 2 minus 1, you have 1. Okay. So then all others, which is the rest, should be subtract from r minus 1, which is 1. So that means the other one changed to the 0, 0 to 1, because you subtract from 1, right? So that means you will have 3, 0, 1, 2, 3, 0 for these 1, 2, 3. You will have 1, which is changed this 0 to 1, and you have 2, 0. Okay? You take R complement and put the negative number in front of that, which is I take the R complement, which is 2's complement here, and put this negative number in front of that. So I'm just putting this inside this rectangle, which is what we got is negative 0.01301. So if you check with what we did for x minus 1, so see it is right? We got the same number, but we just got the negative number here, which makes sense. I actually gave you example in beginning of these example. 5 minus 2 is positive 3. 2 minus 5 is negative 3, right? So this is the same story. X minus y is this. Y minus x should be negative the same number, which is the same, right? So it shows whatever we learn here is definitely works, right? So see what we have in the notes. You just need to follow what you have here, okay? So let's actually finish these topics with just one more example, which is using the first complement. We have again two numbers. One is the x, one is the y. So we have x, which is 1 0 1 0 1 2 0. We want to subtract this from 1 1 2 3 4 1 1. So again, you want to subtract this, but you want to, the only hardware that you have able to add the numbers. So we are going to use the first complement to do that. So suppose this is x and this is y. And the question is, what's x minus y? So just double check these numbers, 1 0 1 0 1 2 0 for x and 1 4 0 2 1 is for y. Yep. So again, back to what we learned in our previous class, I want to do x minus y, but I'm going to do this using the r minus 1 complement. You are in base 2, r minus 1 complement should be the first complement. So that means you need to calculate x plus y double prime, which is y double prime is the first complement of this. To do that, so first keep the x, which is 1 0 1 0 1 2 0. Then you add that with the one complement of these number. What is the one complement of y? How you could write the one complement of these number that you see? You could actually type on the chat box. So how you have one number in base 2, and the question is what is the first complement of this? So we have some similar question in the homework. Okay, so for taking the first complement, you just need to convert 0 to 1 and 1 to 0. Okay, yeah, so let's see if we write that, what we will have. So, okay, I'm changing the 0 to 1 and 1 to 0. So you have 2 1, they will be changed to the 0. Then you have 4 0 should be 4 1, and you have 1 here, you change to the 0. Okay, so 0 1 1 1 0 0 0 will be the first complement of that. So please read the notes that we have and also the homework. Okay, so you need to actually some practice to these concepts. So I just keep the x and take it one's complement of the second one. So this is a number that I got. So then I add just these two numbers. So 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 1 is 2, 2 minus 2 is 0, you have 1, 1 plus 1 is 2, you have 0 here, so 1, 2, 3, you will have 1 here, and 1 carry, so then you have again 2, which is 2 minus 2, 0, you have 1, 1, 1, 2, you have 0 here, you have 1 here, and you got this one here. Okay, you could add some zeros here for the last one. Okay, so this is what I got, which is 1 0 0 1 4 0. So now, based on what we have here and we explain, so let's see which of these two situations happen. So I want to do m minus n. I did m plus n double prime. So check the carry. So what is the carry here in these results that we have? Carry is 0 or 1 here. Carry is 1 definitely. So see 1, 2, 3, 4, 5, 6, 7. You add two 7-bit numbers, you got the 8-bit. Okay. So carry is 1. So let's see if carry, if the sum produce carry, remove the carry and add 1 to sum. Okay, so just remove the carry, add 1 to the sum. Let's do that. So I'm doing with the other color. Okay, so I get rid of this, and again add 1 to the result. Okay, this is the 1, right? So this is how you add the 1. Okay, so it should be 1 0 0 0 1 0 0. Okay, so that means whatever you got is x minus y, so which is 2 0 1 3 0 1. Okay, so this is a subtraction. So here I could add, so whatever you got here is the x minus y. What you did, you actually made the subtraction without actually having the hardware to do that. You just have one hardware which is able to add the numbers, and you use the first complement and able to get the subtraction. So any question about this? It is simple, right? Just follow whatever we have on the notes, right? Just 3 steps for both of them. So for the practice, you do this. So for this, we actually calculate x minus y. So right now you do this. You actually calculate y minus x. Okay, so this is the question. So you know the x, so this is the x, so this is y. So now as a practice, you actually calculate x minus y minus x. So I just need to do this. I just need to say, okay, first I need to calculate y plus this time the first complement of the x. So the y is 1 0 0 0 4 0, right? 4 0 2 1. Plus this time you need to actually calculate the r complement of these number x. Do you see what is the r complement of that? I explained that you just need to change 0 to 1, 1 to 0. So you have 2 0, which is changed to 1. This is 1, should be 0. So then you have again 0 should be 1 1 0 0 1, and this should be 0. So 0 1 0 1 0 1 1. Okay. So this is actually is the y we could actually write here. So it's actually the first complement of the x. Okay. 0 1 0 1 0 and 2 1. So then you just need to add these two numbers. So 1 plus 1 is 2, 2 minus 2 is 0. You have 1 here, you have 3, 3 minus 2 is 1. You have 1, 1 carry here, you have 1, 1, 0, 1. Okay? So now the question is, do we have carry or not? You tell me. The carry is 0 or 1 here? Carry is 0 definitely, because this is actually 7-bit, 7-bit, you add get the 7-bit, so definitely it should be the carry is 0. It's carry is 0. Just back to our notes if you forgot what we need to do. If the sum or carry is 0, take the r's complement of the sum and place the negative sign in front of that number. So back here, and we need to actually take another r complement. So what is the r complement of these number that you see here? What is the r complement of this? R complement actually, sorry, not R complement, one complement or R minus one complement of this. So again, similar with we did for the X, right? So you just need to change 0 to 1, 1 to 0, right? So I start, the first one is 0, change to the 1. So then you have 2, 0. So then you have 3, 0 because you have 3, 1. Then you have 1. Then you have 1, 2, 3, 0, okay? So this is actually is the actually one's complement of that, but you actually take the r minus 1 complement plus negative number. So you need to actually put the negative of that too. So that means negative this number is your subtraction. So if you check this, x minus y is exactly the same thing, which is 1 0 0 1. And the y minus x definitely should be the same number, just you need to have actually the negative sign, which is actually make sense, okay?